Okay, today students, our learning objective is isosceles and equilateral triangles. And to get started, we're going to review some vocabulary that you're probably very familiar with. A triangle is blank if it has at least two congruent sides. That would be this word here, isosceles. I-S-O-S-C-E-L-E-S is how we spell it. When an isosceles triangle has exactly two congruent sides, these two sides are, if you look over here, the two sides are the legs. The angle formed by these two legs, here's the two legs, so the angle formed up here at the top is called the vertex angle. The third side of this triangle is the base. The third side is the base of the isosceles triangle. And the two angles adjacent to the base are these two here, are called the base angles. Alright, we have a few theorems and corollaries to go over. The first one is the base angles theorem. It states if two sides of a triangle are congruent, then the angles opposite them are congruent. Alright, let's label this over here triangle A, B, C. Okay, what this is saying here is that if two sides are congruent, so the two legs here and here are congruent, so if AB is congruent to BC, then what? It says then the angles opposite them are congruent. So opposite angle, if this is my side, AB is my side, the angle opposite is going to be C, angle C. And so then angle C would be congruent to angle A. Alright. The next one is the converse. And remember, converse just switches the order around. It makes the F part of the conditional statement become the then. So the hypothesis will become the conclusion, and the conclusion will become the hypothesis. Okay, so here we're going to start off. Notice how we ended with angles. So we start with angles. If two angles of a triangle are congruent, then the sides opposite them are congruent. Okay, this time I'm going to call this one the cat triangle. Alright, so here I have the cat triangle, and it's saying we're starting off with two angles. So if these two angles are congruent, then the sides opposite them, so the side opposite of C is going to be AT, and the side opposite of T is going to be CA. So here, if angle C is congruent to angle T, then I know that AC is going to be congruent to AT. Alright, the next one. Corollary to the base angles theorem. This is just, a corollary is just another piece, something that we take our basic theorem and then we stretch it. We have it relate to something else. So here, if a triangle is equilateral, now remember, we started off with isosceles, and it says isosceles has at least two congruent sides. It could have three congruent sides. And if it does have three congruent sides, then we call it equilateral. Okay, it has a new name. So if the triangle is equilateral, then what do we know about the angles? All the angles will be the same. So if all the sides are the same, then we know all the angles are the same. So then we call it equal angular. So here, I'm going to call this one tex. T-E-X. So this is my tex angle. And I know this doesn't look like an equilateral triangle, but remember, things aren't always drawn to scale. So here, if I know that all these sides are congruent, so I know that if TE is congruent to EX, which is also congruent to TX, then what do I know? Well, if all the sides are congruent, then all the angles are congruent, so I know that angle T is congruent to angle E, which is congruent to angle X. There you go. Now, here's the next one. It's corollary also, but it's the converse. So it's going to switch it around. So this is the corollary to the converse of the base angles theorem. So we start off with the angles, and we end up with the sides. So this time I'm going to call it the Mrs. angle, or Mrs. triangle, MRS. MRS. So here, we start off with the angles. Then, so F angle M is congruent to angle R, which is congruent to angle S. Then, I know that the sides opposite them are congruent. So, I know that MR is going to be congruent to RS, which is also congruent to MS. Okay, so that is basically our lesson for today. So I'm going to go over a couple of examples, and then you're going to have a check for understanding section that you're going to have to do on your own. So here's page 2. Alright, so here's an example of what you might see in your homework. Right here, it's giving you a triangle DEF. Triangle DEF, and in the triangle they're telling you that side DE and is congruent to side DF. So these would be the legs. This would be the base, and there's my vertex angle. They want me to name two congruent angles. Because of the base angles theorem, I know that the sides opposite these are congruent. So remember, when we are naming angles, we name the angles using 3 letters. So just write yourself a note, use 3 letters to name angles. So I'm going to name this angle here EFD, and the other one is going to be this one here, which is angle, let's see, this one here is going to be angle FED. So those 2 angles, it says name the 2 congruent angles, and there they are. Now, when you see this, sometimes you'll see it when you're checking your homework, and we put up the answer keys, you'll see just angle F. They'll write this as angle F, or they'll write this as angle E. And that's because it's easier for a publisher to just put one letter so that it's easier for us to grade. So we just look to see what the vertex, what's in the middle. Because we could really write this angle right here is DFE. We could reverse these letters if we keep F in the middle. And if we keep E in the middle here, this could be rewritten as DFE. So that's why you'll see publishers just use one letter. But the proper way to name an angle, remember, is to use the 3 letters. Okay, so now, example 2, find the measures of P, Q, and R. And what I have is this triangle here, and the triangle has been labeled with these hash marks, meaning that all of these sides are the same. So I know that I have an equilateral triangle. And because of the corollary to the base angles theorem, when it's an equilateral, it's also equiangular. So I know all the angles are equal. Okay, so now I can mark all the angles equal. And when all the angles are equal, I know if all of these are the same, that means that, let's say call them X, let X equal the measures of angle P, angle Q, and angle R. So if you let X be the measure of each one, then you say X plus X plus X equals 180, or 3x equals 180. Divide by 3 on both sides, so x equals 60. So that means that the measure of angle P equals the measure of angle Q, which equals the measure of angle R, and they all equal 60 degrees. Okay, so that's how I write my answer. Okay, the last one here. Find the values of x and y in the diagram. Okay, so here, if I start over here to the left, you're going to see this triangle right here. And this triangle right here has all of these angles marked. And according to the corollary to the converse of the base angles theorem, when you have all the angles marked, we know that all the sides are the same. So now I can mark all these sides are the same. So I'm putting one hash mark for each one of these. So right off the bat, I can find y because I know that this whole side is y and this whole side is 4, so I know y equals 4. So I found one of my answers. Okay, now let's look at this triangle here. And what you see in this triangle is two little hash marks here. So that means that these base angles are congruent. So that means the sides opposite them are congruent. This one already has a mark of one hash mark. So that means that if this is one hash mark, this has to be one hash mark. And yes, that means that this side and this side and this side and this side, they're all the same. So I know that x plus 1 must also equal 4. Subtract 1, that means x equals 3. Okay, so that's it for the notes. You have this check for understanding section. And the check for understanding section has 1, 2, 3, 4, and 5 different sections. And in each section it has a range of 2 to 6 problems. You're expected to do these problems. I'm going to do a couple for you. I'm going to do this one here. And all of them are the same in this section. So in section 1, you'll see that all of them look the same. Okay, so we're going to do this one. Here, I'm told that ABC is an isosceles triangle. Find the following. Just vocabulary matching. Vertex angle. That's the one up here in between. You've got this leg and this leg. So this right here is going to be the vertex. So that's going to be angle. And it's A, but remember we have to use 3 letters, so that's going to be BAC. And yes, you could have put in CAB. That would have been the same. Base angles, those are the two that are congruent at the bottom here. So sometimes the triangle is going to be turned on its side, like this one over here, or this one over here, or this one. So it's not always going to be at the bottom, but it's always going to be the two base angles are always going to be the ones that are congruent. Okay, so here, this is going to be, the base angles are going to be angle ABC for this one, and angle ACB. The legs are going to be the two congruent sides, so that's going to be AB and AC. And now the third side, the base, that's going to be the non-congruent side, so that's going to be BC. Now, it could be congruent, because remember, it could be an equilateral, but in this case, we just have the two sides marked as congruent. Okay, you're responsible for this one, and this one on your own. Okay, let's move on to the next one. Number 2, I'm going to do this one for you. Okay, you're given this diagram, and you're told to find the missing angle measure for each triangle. Okay, now remember that the triangle sum theorem tells us that all 3 angles add up to be 180 degrees. So here, we don't know this one, We don't know this one, but we do know this one. I'm going to start by let x equal the measure of angles L and N. Okay, so here I know that this one's x and this one's x. So x degrees and x degrees. So that's going to be x plus 40 equals 180. Simplify the left-hand side by combining like terms. I get 2x plus 40 equals 180. Now it's just an algebra problem. Okay, we're going to subtract 40 from both sides. I get 2x on the left equaling 140 on the right. Divide both sides by 2, and you get x equals 70. So that means that angle MLN is going to be 70 degrees, and angle MNL is going to be 70 degrees as well. Okay, you have this one, and this one to finish. Alright, this one, number 3. Okay, let's mark this. It says, in triangle LMN, angle L is the vertex angle. Okay, so this angle L, this is your vertex. It's a vertex angle. What that means is this side is going to be congruent to this side, and this is going to be your base over here. So it's kind of tumped over on its side, and it means that this angle is going to equal this angle. So that's all the information that we know. But here, since I have it marked, I know this and this, these are the same length. So I can say 2x plus 5 equals 5x minus 7. So once you set up that equation, 2x plus 5 equals 5x minus 7, I will be able to solve this using my algebra skills to find x. Once you find x, you need to plug it back in to find these 3 sides. So the rest of this is going to be for you to finish up. Alright, number 4. Number 4, they're all the same in this section. So I'm going to do this one here. It says write an equation for the isosceles triangle and then solve for x. So here, these are my 2 congruent sides. So these are my 2. These would be my congruent angles here. So what I have to do is set them equal to each other. So my equation is 4x minus 20. Those are equal to 3x. So that is an equation because it has an equal sign. That one is fine. There are other equations that you can write, but that's the first one. Okay, so now that I have that, 4x minus 20 equaling 3x, if I solve this, I'm going to move the x's to one side. So here, if I do this one, it's going to give me, if I move the 4x to the other side, it's going to give me negative 20 equaling negative x. But that's not the answer because I don't want to know what negative x equals. I want to know what positive x equals. So to get rid of that negative, I just divide both sides by negative 1. And x is going to equal 20. The rest of those are for you to do. Okay. And there's a couple more up here. Alright, so here's the last section. And you will see that we start off here with, this section is just finding x and y. We start off here with an equilateral triangle. And we know, we found out from an earlier example that when we have an equilateral triangle, all the angles are equal, and because they're all equal, we know that each one of them is 60 degrees. So that's 60, this is going to be 60, and this is going to be 60. So I have found x. I know it's 60 degrees. Then I have this mark right here. This mark is pretty important. That's 90 degrees. So this much of it is 60. How much is that part of it? Well, that's just 90 minus 60, which is 30 degrees. So this angle right here is 30. Well, that's, if you look at this triangle right here, that's an isosceles triangle. So since 30 happens to be a base angle, that means this one over here is 30 degrees as well. To find y, what I have to do is I have to say y plus 30 plus 30 is going to equal 180. Cleaning that up, y plus 60 equals 180. Subtract 60 from both sides, y equals 120. So my answer for y is 120 degrees. There you go. So the rest of those are for you to do. And that's it for today's lesson.